Okay, I guess we have got like 20 folks and we can start, I guess. So, like, if you're comfortable, can we?
Yeah, yeah.
For the new folks who have just joined, I would like to introduce, so for once more, what ML Math Club is, what TFUG Ghaziabad is. So, hey everyone, I'm Vedansh from TensorFlow User Group Ghaziabad, the one of the world's largest TensorFlow community. Recently, we like crossed the benchmark of 5,000 plus members, and we are like really strong right now. This is our newly launched campaign called ML Math Clubs. Here we will be having like a month wide. This is a month wide campaign. We will be having some sessions on weekends, in which we will be telling you about the mathematics, mathematical concepts that are involved in the study of machine learning. Well, what's the best way we can start it? So we have Santosh Kumar here, who is a data engineer to at Rakuten, and he's also a 12-time hackathon winner and also a six-time conference speaker. So yeah, we have someone who is like really experienced in this field. And guess what? What topic he has for us is like, does math really matters to understand machine learning? Well, a lot of you are always like skeptical about, okay, I have to learn maths in order to start machine learning. You are also have a fear of that. Well, sir is here to like solve all your doubts about that. And I would like to hand it over to sir. Sir, please take over
Thank
the
you. Thanks a
stage.
lot for inviting Akash for the invite. So cool. So we'll jump in right away. So I don't want to bore you guys with equations or math. So nothing of that sort is in my slides. So mostly it'll be text. I'll remove myself from the. Cool.
Sorry, sir, but you will have to remain. Your mics get shut down if you like get it away from it. Maybe we can adjust you somewhere else, or you can try a different view for presenting.
Okay, if I remove myself from the stage, 1 second. Okay. Okay. I think this is what we have to adjust with, I guess, this platform. Cool then. Cool. I'm Santosh, and I work as a data engineer at Rakuten, and I've been actively participating in hackathons from 2021. And I did start with ML way back in 2018. So move to my next slide. So I've been doing a lot of work in ML space from 2018, as I said. Then back then we didn't have all these fancy libraries and tools that you guys have now, which you can really utilize to kind of kickstart your ML career or ML ops or anything that you do in ML, even just the learning part. We just had Kaggle, so I did a lot of Kaggle back then, and this is what I've been doing so far. So I'll just skip this slide and read about it later. So in the agenda, so what we are going to see is why I started ML and how I started it, and basic introduction of artificial intelligence and what differentiates it from machine learning. So most people use it interchangeably, which is not absolutely wrong, but there are few kind of terms that you have to definitely know if you are at least taking up an ML engineer role, or if you are started learning ML. So you should know that these two are way different terms than it looks. And there are two things that I want to share today when it really matters to have math as a background when you start with ML, and when it is not. So there are cases where you do not need a strong math background to be an ML engineer in the first place, and there are few instances where you might need to be a better good at mathematics or calculus or linear algebra, for example, to be good at ML job. And finally, what is the current thing that is going on with ML, with LLMs and things that we'll discuss later. And finally, we'll have some Q&A, so you guys can have questions. So you'll have ample amount of time. I don't want to bore you with all the slides that I have. I just have 10 slides including all this. I think we just have 7. So I'll be very quick and I can answer most of your questions. So when I started with ML, I'll skip to the next slide. Excuse me. So 2018, so we had this competition called Yantra. I think still you guys have. It is organized by IIT Bombay, which is really good. Where you get to explore most of the things in ML. So when we started out in 2018, there is this competition where we just enrolled. We didn't know what is ML back then, so I did Python on my own. since I did electronics and computer science, electronics and communication, there is no computer science, or I just had two subjects to it, so I just have to self learn all the things from scratch to be able to get into ML space. And that is how how I started. And that competition really gave me how things really should be. And we had a lot of things that were working and not working. And we did have four people in the team to be able to develop a model which can predict out. I just don't even remember the problem statement now. So you just need to create a model which predicts out something. So that is how I remember it. But that is where we started writing bar code. So even a sigmoid is a activation function where you have to write the actual sigmoid function and not use a built-in something. So that is the level of basics that we have to go through to get through the competition in the first place. There are multiple levels. So first level is your screening round, and then you have to submit your solution, and then some peers will review it, and then they will select you to the on-site round, and where you have to go and win the prize. And last year, year before, one of my senior, I think he won third prize, I guess, in IIT Bombay. So that is one of the things that motivated me. Like, let's say we'll try this year out and then see how things roll out. So that is why we started with Yantra, and then why we started with machine learning as well. So how I started with machine learning as well. So learning with the competition is one of the advantage of when it comes to rapid learning. So you get to learn something and then implement it right away. So that is one of the key factors that uh, is driving me even now. Same with hackathons as well, where you get to learn something and then you kind of do it on the hands on right away. It is not even just days or months. So you just learn something for 2 hours, and then next hour you try to implement it. So that was throughout the competition. It was that case. And we did get on all sort of things to kind of get hands on in machine learning and ML, so to be able to kind of compete in that competition. And back then we didn't have or at least our team didn't have a lot of ML background or ML to start with, even not even Python. I think I have just started it, but not like a core programming in Python, since I'm mostly in C and C++ when we started out. And we didn't have traction of Python back then. We started getting the traction after this ML boom started, where most people were into Jupyter notebooks, and then Spider was back then. One of the two Anaconda was one of the famous things that no, even I started using Anaconda first time when Yantra started. So I just know that you can do something with VS Code, and that is how we were using. And PyCharm is one of the things that you can use definitely. But VS Code is what I started with, and then PyCharm, Spider, and all these things came by when I started with the Yantra. And the second part is where it is not just a competition, I would call it is like a framework where you start learning ML, right? So it is just not a competition when I started. So that is one of the things that we were able to at least complete the solution and submit. So that is one of the factors. One second. So that is one of the factors where this competition was really helpful in developing a good ML background, to be specific. And this is one of the things that I love about competition. So it is not just you already know a lot of things and then you compete, but it is mostly you learn something and then you start competing. And there's a gradual learning process as well when you start competing. So that is one thing that I liked about how this competition was held in the first place, where they give you like a lot of details on how have you can build a model and what are the things that goes into the model, lot of references, videos, blog links, and etc and etc. So all these things were foundations to it. And even we did share all these with our professors to for them for their improvement as well. So we didn't have like courses on ML back then, way back in our college days. So they also started using it and they got an understanding of how things work, and then they were trying to help us as well on the go. Since we had like three internal teams in a department, and there are few more teams as well in around the same area that we had our college in. So there is a lot of competition even within our region, and you have to compete on the whole nation as a whole. And there are a lot of good people and who have a lot of good resources as well. And that was really fun competition, I would call. And that is was the one of the turning points where okay, you can learn something and learn something with a competition. So that is one of the triggers that I had to start participating in hackathons, where hackathons is much shorter span. So let's say it can be 12 hours, it can be 6 hours, it can be 24 hours, it can be 3 days as well. So these are the various ranges of hackathons that I have participated. 6 hours was the least, I would say, which was in 2020. Uh, it was Airbus Areathon, which I think happens every year. We participated in the second edition, I believe. So ISRO chairman was attending the function in the evening. So that was one of the shortest hackathons I ever attended. And there was this hackathon, Codicon, which happened. I don't know the office name. I don't remember it. Sorry, but we had around 2.5 days, I guess. So there are two different types of hackathons where you get a lot of time to solution, to present, to think about the solution, and change things. There are hackathons where you have to go fully prepared, and then you get a problem statement and you start solving from the first second. So these are the things that you learn as the day goes by, but still this is how do a rapid learning. So it is not like you take 6 months to learn ML and no, you go nowhere with 6 months of ML. So that is one thing I would like to call out. So you don't have a lot of time to learn stuff. You have time in your college, but once you get out of your college, and even in college, if you want to be better than your peers, obviously it is the time constraint that you might have. So you have to invest a lot of time in upskilling yourself than your peers. Even in placements, even though he is your friend, you have to get placed and you have to score at least a point more than him to get into the placements. So it is really competitive. So you will understand once you get to a point where you are competing with literally everyone around you. So it is really competitive out there. And even if it is in college, and think about at least for a company or any place that you go, it is highly competitive enough. And many people are aware of how things work and how you should prepare. So that is another big challenge that you have. So since everybody knows everything, so it is very difficult to kind of compete. You have to be at your max level to compete against all the good programmers out there. And I did the same very similar ML project in my final year. And one breakthrough thing that I was able to do is, I don't know, web application or any front end or back end thing. And then my professor was like, can we deploy somewhere so that we can show it? It's not just Jupyter notebooks. So Jupyter notebooks are the older version of where you show outputs. And my professor like keen like, can we do it in a different way? Why can't we present it in a more better or elegant way than just running few cells in Jupyter notebook, which doesn't make any good user experience? Then I was like, okay, can we do it? So I think it was a Sunday afternoon or a morning. Then I was like, okay, can we try it and deploy it somewhere? So Heroku is one of the free platforms back then. Now I don't think it is free, and I'm not using it enough. But back then it was free, where you can have a Postgres DB, or you can deploy a container. So back then I still have the code in my GitHub repo. If you guys want to see the old code, which is written in way back in 2019 or 18, which got deployed. And after that I deployed the same code in 2020 for some reason, 2020 end, and it was not working. So there was an issue with Python versioning. So Python was deprecated, I think 386 or so, 386 or 389. 386 I think was deprecated. And I'm not sure on the exact number. Some version of Python was deprecated, and then when you try to build Docker image, it throws an error. That was really painful. Even though people say that you can use Docker to deploy and it just works, it is obviously not, unless you use the right long-term uh, version of Python which is supported. 3.8, I think most of the generic 3.8 version support, and but the minor version 3.8.6 or 3.8.9 or 3.8.8, all these minor versions might be deprecated in the near future. So you have to be really keen in what you're using with the Python versions and things. Even though you have a requirements.txt or USP freeze to create the requirements.txt with all the good versions, if the Python version itself is changing, or if that particular Python version is deprecated, then there is no use in having all the requirements in place for that particular version that is going to be deprecated soon. So that is one thing that I would like to call out. When you're hosting it anywhere, it is not just Heroku. You containerize it, you push it into Azure, or you push it into GCP. Anywhere you try to host it, and maybe just put it in Cloud Run. Anywhere you try to host it, it is kind of a pain when it comes to deployment of things. And once you start deploying things, it gets easier and easier, since you figure out all the issues and bugs and all the issues that you might come across. So it gets way more easier when you start doing it frequently. So you know all the procedures. This is this might be a problem. You can solve it now itself, so that you don't have an issue back after you deploy or after you have started your prediction, or it might run slow for some reason, and you don't have to load the model properly, or every request loads the model. So Flask application is one thing that I have used to deploy the model. So what happens is, so once you have the model load function inside your request, so every time you have to load the model. If the model is around 20 or 30 MB, it is okay to do it. It is not like production grade, but it is okay to do testing or have dev version of things. But once you productionize stuff, let's say if you're hitting 100 requests on your Flask application, even maybe in your local machine, it might load up your RAM, since every time you have to load 20 MB file, maybe a pickle file that you have, or h5 file, whatever file that you have the model in. So it is very difficult to kind of productionize stuff in real world. So you can do it on a local machine, share it with your peers, or maybe your professor, even show it all the fancy stuff. But productionizing things and making things work at a higher scale, and high scaling is one of the not difficult things, but we are not taught how to do it properly. So that is one of the things that you have to definitely go through. And yeah. So, and finally, we had a paper published in one of the journals that is out there. Most of the efforts due to my professor, and we had a lot of iterations to go through. So it was one of the pain that I have to literally go through. So it is not like coding where you know the exact output. Since they have this strict review process, it should not be plagiarized, or you can't have. There's a percentage of content that you can have, and there's a percentage you can't cross for every page or something. So these are the things that I learned the hard way. So it took, so deploying the project, and I think building it took at least I think just a month. So I had a gaming laptop which had 1060 GTX. So it was able to do it. I think 10 hours of training time I did train the model. It was an image classification, um, a leukemia process where you have to detect blood cancer. So that is one of the projects we did, and we did publish the same in the paper as well, and how you can do it with convolution neural networks. And finally, after a few years, then I tried to deploy it in Azure functions, and GCP. I have not touched it back then, so I started deploying it there as well. So just to see if we can do it, different place with the same code and everything. So that was one of the good experiences that you have where you deployed in multiple places, and I started using Cloud Run as well now. So you can definitely use it in multiple platforms once you have a stable code, which you can readily deploy it anywhere you want. So that is one of the things that you can definitely do when you write, even if you write a very basic code, very basic model that you're trying to just load and do some predictions. You can make sure that the platform support is there, and you can just deploy it in any platform that you want. So enough of what I did. So I think most of you have good idea of what is AI, and at least for now, you should have heard the term LLM or ChatGPT or GPT. So it is very predominant, and everywhere people talk about it. Even when you present something in in companies, they expect some kind of artificial intelligence to be in place. It is not just the buzzword, but it is something that people really need. And it kind of has this niche where no other technology had previously. Previously, blockchain and crypto was one of the widely spoken topics, and people were saying that it could change the financial system altogether, and a lot of things were spoken by a lot of people who are in the place where they can make a really good change. But they didn't really pick up. There are few adoptions, very few adoptions I have seen, very live adoptions, and we do have an internal team working on blockchain. Every company has, but there is not a wider adoption of things, since it doesn't solve anything that we have as a pain point, right? So it's all something in the back end where it more pushes more for transparency, but it is not solving a need where you are impacted right then and there. But with the advent of ChatGPT and large language models, the impact is more clear and visible, and it impacts everybody. Even if you're a college kid, or you're a mother, or you're a father, or even if your grandfather knows how to use a computer, he can definitely get some good things with ChatGPT. So this is how the impact of building anything. So it is not just the product that you build, but what is the large scale impact that it could have? So let's say if the ChatGPT was not officially launched as a free tool, and it it remained paid for some reason, right? So Codex was the first auto code completion tool that I used. So Codex is GPT 2, I guess, 2 or 1.5 ish. So that time I was participating in a hackathon where I got, I think, $15 of credit to use that to build a VS Code extension. So that was the first time I saw this thing in action, where it really opens up your mind that have a system can predict what you're going to type next, or how it can auto complete stuff. So earlier, when you look back in 2000s, 2005, those time we had Vim and Emacs, which was one of the which is very similar to VS Code and PyCharm if you want to take the battle.it out. So back then we didn't have this auto completion, we didn't have this formatting done, or you don't have any of the uh, tools that we have, sophisticated IDEs, so that we called. Back then we had text editors where you can edit something and then you save and then you close the file. So that is pretty much how we know in the olden days that we had. So we didn't have any need for a integrated development environment, which is called IDE now, where you are more sophisticated and the a lot of pain from the developer is removed, right? So when you start using Python, it is a huge pain when you have to when you use a text editor to edit. So let's say you vim and the Python file name .py, and then if you add spaces to where you should have tabs, and you would get an obviously error, indentation error. So these are the pains that an IDE can easily solve. So when you do format, when you do Command Shift I, it formats the entire file. So you would know the error even before it gets, even when you even before you run something, or you just visually get an error that this line is bad. So back then there was nothing. So there was nothing of that sort where you just say, you just in and wherever you want, in whichever place you want, you can just set what should be the tab, say space. So there are a few places where you use two spaces for tabs, and there are places people where use four spaces for tabs. So those are the only few options that you can change in your text editor. So now when you have the sophisticated tools where you say, let's say you take a pandas and then you say pandas dot or pd dot, let's say you import pandas as pd and then you say pd dot, and you can start, you will get all these list of recommendations that you can start using. So that is the second phase of evolution of how things work. And it is a hard coded value, so it just shows all the so when you use Python dir and the method or an object, it gives you all the methods that the object has that you can use. So it is just listing out all the methods that you can use, and when you start hovering on them, you will also get the docs corresponding to it. So the docs will have an example of how to use the function and what are the parameters that you can pass, which is optional, what are the default values, so on and so forth. So these are the second evolution where it gives you hard coded results out in an IDE. I'm taking an IDE as an example so that you can better understand how things moved and then where we are now. So any questions, please drop it in the chat. I can answer it in between so that kind of. I know this is there are two kinds of people where they kind of wait for the questions to be asked at the end, and there are few people who are okay to ask the questions in between. So I think I am the second person. So if you have any questions, please feel to drop. So I'll answer that and then I'll continue so that it is more easier for you to understand other following things that I would about to say. Cool. So what happens is when you start doing it, when you say pd dot and then you have all these list of questions that you might have, sorry, all the recommendations that you would have, and then you can select something from that, right? So it is not selecting anything for you. It just the chronological order, it just shows all the methods that what the object supports, right? So once that is in place, so you can select the object and then you can read the docs and all these things. It will be easier, much more easier when you start doing all this, and it becomes much more easier when it can recommend you the, maybe let's say you have created a data frame and then you want to filter something out, right? And then let's say it can what if it can give you the filter, let's say let's say let's call df as the data frame, and then df dot query, and then you write a column name equals, let's say if the we need to all get all the community members of TFUG, and then you write the filter as TFUG, and then you get all these records, or we just need to count how many people are there. So you can definitely get that. But what if it can generate that automatically when you have created a data frame, and then you just start writing a comment on the top saying that filter TFUG members of this particular region, or maybe in India, and it gives you all the it starts writing the code. So the first part is just an IDE without any of the recommendations that you get. Second is where you get some recommendations, and this object has all these methods. And the third part is where you get the actual code itself. So the programmers back then has to be really skilled, and they should really memorize everything, whatever is the syntaxes and what everything means, right? So you have no clue when you open a text file and then you start typing Python code. You will realize that it is very hard for you now to really type. Let's say if you ask your manager, or if someone with 20 plus years of experience to do that, it might be easy for them since they have started with their career with that. So just opening a text file, closing it, and then they run. So that should be easier for them. But when you guys do it, or when I do it, it is really hard. When you write de and then you hit tabs twice, and then it has to fill everything. So there should be a boilerplate code that should automatically display when you start writing de in Python. So def and then function name, and then all the parameters can be configurable, and then you start writing the function name and you press tab again, and then you start writing the code. So this is how sophisticated that the tools have become, which is really good and then bad in both the cases. So I'll just say why it is good and why it is bad. So in the first case, where I have seen people using docs parallelly with their coding environment, so that you have some reference to it. And in Emacs, there is an integrated way of showing up the docs. In Emacs, I have seen very few people using it, and I was fortunate enough to see someone live in action where he started typing, and then there is this. So there was this thread program he was trying to write, and then what we were trying to do is. So there is a problem when you write log files with threading and multiprocessing, where one thread may try to write to a file, but let's say if the file is exceeding a particular size in GB, so when you try to write a file and then it exceeds, so the next operation for the thread is to kind of create a new file and start writing the logs in that. So the problem here is if there is a second thread which does the same, and third and fourth thread may know that there is a new file that is getting generated, so it will start writing the logs in that. But the first two threads, it might be really hard for that thread to understand how come it is not able to uh, create how come it is able to create another file instead of writing in the first thread. So this was one of the problems we are trying to solve. And I didn't ask him for the entire solution. He was trying to explain how we were able to identify what is the cause. So this was the cause, and we were trying to understand how we can solve it. So we just had a simple queue where you can dump all the logs, and we had a specific thread which specific process, so to call, which writes to the log files. So we were not directly touching the log files as such in the Python program. We were giving all the logs to a thread, to a process, and that process is responsible for writing and ordering the log files. So you go from 16 people trying to write to the same file, from 16 people trying to give that logs to someone with the timestamp, so that you don't the order still is the same. You have the timestamp, and then you push it to a queue, and then the last process tries to write into the log files, right? So that is one of the things that we were trying to solve. And I have never touched, I think multiprocessing we did touch, but there are few things that you may not know. One second. So we were trying to fix that thing. I'm sorry for the interruption though. Cool. So we were trying to fix that, and then there are few things that see, multiprocessing and multi-threading, you don't do it on a regular basis, right? So there are few things that you do occasionally, and there are very few examples where multi-threading and multiprocessing in Python can be really useful, due to the fact that we have a global interpreter lock, which doesn't allow multi-threading to be that effective as other languages, since it can run only one particular thing at a time. And this global interpreter lock is a huge issue when you're trying to write, when you're doing trying to do multiple things at the same time with the same variables and with the same context of the Python code. So it is not that effective, but we were able to find a solution, and this guy started referring the docs. And then when you start writing, let's say import multi-threading, and then you hit dot, and then it was not giving anything. So ideally an Emacs editor will never give anything of that sort. So every time he has to refer to the documentation manually, and then copy paste the code, or he has to by heart the syntax and which method is in which module, and then he has to import all these things. But now, once you start writing code, obviously you won't write any code which you may not know, so you just copy paste it from somewhere, obviously. Even most of the times we do, even I do. So what happens is, where you have to just copy paste the code, and then you do command dot, and then you get all these recommendations. You can import this particular package, this particular method from this particular module, or this particular Python package as this particular method. So all these recommendations you get, uh, which is really fascinating to me when you start, how they started and how things are rolling out now. And coming back to what is artificial intelligence, I have spoken a lot. So the third part is, so this example I'm giving you just to understand, how this artificial intelligence is coming into the picture, and what is the capability that it is bringing. So it is eliminating the human part out of the equation, where you just give some random input, not random input, things that you might need, and then it is giving you the answers that you need. It may or may not be right. So let's say 80% of the time it is right, and then 20% time it hallucinates, and then it gives you a buggy code maybe. But most of the very simple codes that you might get would be obviously right. And I have seen, personally I've experienced with copilots, it is most of the time it is right. And then it is really fascinating to see how fast you can write code, since it really tries to understand. It doesn't really understand. I'll talk about LLMs and how things work at the end if I have time. But still, uh, it is not trying to understand, but it has the context of what you're trying to do with the data frame. Let's say you do a data frame, and then you have to do a group by, and then find out all these people, and let's say potentially how many people might join. So all these things we are trying to find out. So every step gives the LLM more context of how, what you will do next. So that, this is one of the fascinating things that you might have to understand very clearly of how things exactly work. I don't want to read through the slides, you can definitely go through it. So this, what artificial intelligence as a, it's a whole or an umbrella means. So now coming back to machine learning. So as you can see, machine learning is a subset of artificial intelligence. Most people use it interchangeably, which for most cases it is totally fine. Even in on stage, CEOs, CFOs, CTOs most probably use it interchangeably, which is definitely fine. But as an ML engineer, even though I am a data engineer who started with ML and then I moved on to data engineering, when someone is using that interchangeably at this level, right? So you are an ML engineer and you deal with models every time, every day, let's say, and you use it interchangeably. It is really bad on your side if you use it interchangeably and you don't know exactly what it means. So it is machine learning is a approach, or you can call it human mimicking machine, or a program, or a tool. So all these words I'm using, I'm not, so nobody knows which is right till now. So I'm just using it all across, so that it is just out there. So if every of this thing means the same, or an approach where you are trying to do some work, which that particular system is trying to do. So system is mostly common word that is used to describe a machine learning model. You can call it a machine learning system. The system has to do some work or some task that it has to complete. right? So this is way different from what is AI. I'm not able to think of a better example, but this should be good enough, I guess. So if you have any questions on this, definitely drop it on the chat. So now, why it really matters? So the important question of the day. So why math or any of the things that you might have studied on your schools, grad schools, might be useful, or is it really useful? So if any of things that you're doing on the list that I'm showing over here, so this I just typed it out, these are very few things that came to my mind. So let's say you're developing your own algorithm, for example. So you're trying to build something of your own. So you're trying to build an architecture of a model. So every model has a different architecture to it. So if you're trying to implement an architecture of your own, definitely you need some bit of math, since everything works on maths. Even everything that moves has some equations that you have to solve, and you have to come up with some numbers at the end. Even even the text that you send to ChatGPT is encoded and it becomes a number at the end of the day, and it is multiplied with weights again. So everything that you might see or hear, everything is a number, and then it has some meaning to it, and then it goes through a mathematical equation, of course, on of any size and any magnitude. So to be able to give a good meaning and understand. So second point is very very important. So if you want to really understand how exactly things work, let's say take an example of a binary tree, or a decision tree, sorry. So if you want to understand, so it is one of the very easy examples to understand. Let's say it is a bunch of if else statements that you can use to figure out what which bucket this particular maybe the value input values belong to. Let's say three different classes that we have, and we can take which class it belongs to just by uh, comparing the values of comparing the input values. So it is very easy to understand, kind of an ML model where it is very basic, as well as it is easy to understand, but in scaling it might be very complex to kind of visualize things. But we are able to understand why it is doing it, right? Say if your heart rate is above 120 or 150, that means that you're doing something heavy. Maybe you're doing a workout, or let's say your heartbeat is less than 50. So that is a very critical situation. So binary tree will just have greater than or equal to, greater than or lesser than, to determine whether you might have a heart attack or not. So it is very easy, or whether the heart is stopping or the heart is pumping too fast. So it is very easy to be able to understand. There are few models which you may not be able to explain right away. Let's say for example a very basic CNN model which tries to understand if the given image is a orange or maybe an apple, right? So it is very difficult. There's always a black box in between the your input and the output, where you're trying to figure out things, right? So it is really important to understand. So you can get closer to it, but even with the mathematical equation and you do solve all the numbers in between, there's always a black box, in at least in CNN. I can talk about CNN a lot since I have worked on it. I'm not taking all the other examples. So we have RNNs, DNNs, so all that I'm out of scope for that. But CNN, since I have worked on it, I can really tell. So what happens is it breaks down a particular image. Let's say you have a image, let's say 128 cross 128, and then it tries to have these filters and frames, where let's say 4 cross 4 frame, and then you try to place it in a different shape, or you move the pixels around to form different windows. I think most of the cases it is windows or filters where you, so that is where you kind of segment all your images, or you segment a particular image with pixels, right? So once you start working on a pixel level, you will understand how good things are when you look at it at a very deep stage, right? And that is how you have to understand. But there are few cases where you are not able to explain why it is doing it. So there are a lot of cases where you say this particular image has a blood cancer of this particular type, and then you are not able to explain, and the model will give you a confidence level that why it is saying it, but you don't know what is the reason behind it. So it is not giving you the exact reason. Let's say if I can justify, you are giving me an apple, and you're asking me whether it is an orange or apple, and then I say it is an apple, and then I can justify that the outer coating of it is smooth, and I'm also justifying that if it is an orange, the surfaces should be rough, right? So that is the justification I'm giving you, so that you are convinced, totally convinced, that he knows what an apple is, right? So I can bluff also. So since it is 1 and 0, so you have 50% chance of getting the answer right, so you can even bluff. So the justification is not very clear on most of the your advanced models, why it is giving what it is giving. So it is very hard, and it is still a black box, and people are trying to visualize stuff with all these weights and biases running around. And there are few very good visualizations of LLMs as well and how things work, but it is very complex architecture in example, and to understand as well, and everything is in mathematical form. So if you are really interested in all learning all this and getting deeper into it, then you definitely need math. And for all the other things, you can definitely read it out. So strength and weakness, you should definitely learn with once you start understanding all these things, you should definitely go with it. And solving and troubleshooting, this I don't think it really matters, but it is again relates to the second point, where you have to know why it is giving the value it is giving. So if it is saying apple, why apple? If it is, and you should also ask the question why it is not orange. So there are two justifications that you have to give. One is yes, so yes, this is apple, and this is why it is apple. And then you should also give a justification that this is not orange, no, and then why it is no. So those are the justifications that it is very difficult for an ML model to give. So confidence is one of the things that you can consider, but it is not very clear that why that confidence level is, right? Even if it gives you a confidence level, we are not sure the factors that are contributing. Let's say if it says 70%, 72% confidence, and you should know why it is 72, why it can't be 80, why it can't be 60, why it can't be 50. So even 1% confidence means there is a possibility of 1% of this being right and 99% of this being wrong. So but the justification of why it is 1% and why the 99% it is not, that is not very clear. And if you're very fascinated, then this is the place that you have to definitely explore. How, and these two questions, if you're able to answer these two questions in any of the ML models that you pick, then you have the ability to understand and read the models, which very few people in the world can do. And this is one of the demanding skills, since you can build better models if you know why it is giving what it is giving. So this is one of the things that fascinated me for a long time. And yeah, and second part, this most of 80 to 90% people will come into this space where you don't have to know what ML. It is not like where you don't know exactly how it is working, but let's say for this particular category of problem, this category of algorithms can be used. Let's say clustering, use a k-means. So regression I can use for time series. So all these uh, correlations, that if the problem is this, then I can use this particular model. So you don't have to understand the math behind the model, but you need to understand what model to use for what particular problem. So this is a high level knowledge of machine learning, but it is not like a very deeper level of things where you learn the things that I've said before. Second thing is if you're using a framework or library. And third thing, if you want to deploy, so most of the times what happens is you have to deploy something very quick, and then let's say you have to just detect sentiment of a sentence, right? So for some reason, so there's a huge process that is running in, and you have to definitely get the sentiment of the sentence for some reason, so positive, negative, or neutral. So you can't just think of a model, come up with training data, train the model, and then deploy it, right? So it is not, so the project is not focused on training a model and deploying it, rather than, let's say if it is a customer support work, and then you have to get all the sentiments of the customer, what he's trying to say. So the problem is, problem solving is with the way that it is said, and what is the process next after what is the customer is saying, and not the problem is with the building the model and telling what it is. So that is one of the things that you have to understand when someone says bring it quick or do it quick. You don't have the time to understand the model, do some training or fine tuning of the model. You don't have time for all that. You just go get the model from Hugging Face or anywhere that you can find, and then start using it right away. So those are the things that you have to definitely understand, when you have to be like proactive in delivering stuff, and where you have to proactive in learning stuff. And the third part, I think PyCarrot, I think most people might have. So this is very very old framework. When I was using it, so what it does is it runs. So you are not very sure on how. So the earlier example that I was saying, where someone knows what, say let's say clustering, have this model is way better. So PyCarrot, what it does is it runs all the model through all the training data that you have, and it gives you a tabular information of what model is performing better, and what is its accuracy, precision, recall, and all the metrics that you would need to decide which model is the best. So this is one of the initial AutoML frameworks, you can call. It is not actual AutoML, but this is one of the initial frameworks where you compare. So it is most of comparing between models, and it is not giving you a selection, but it can give you, let's say, the top three models that this particular data set, these three models are very much suited for this particular data set. So it can be a very high level information on that. And the last part, you don't care about optimizations of the code. So this is one thing that, let's say, if I'm okay with 85% accuracy, I just need to deploy something very soon. Let's say in 2 or 3 days I have to deploy something. I'm okay with 85 to 90% accuracy. And a real model in a real world scenario, I have heard from a lot of people that the accuracy is not like 95 and above. So 85, 85, 80 to 80 plus is a very good score, and 90 below is fine. So I don't think there is a model in a real time scenario where it is doing all the predictions, which has an accuracy of 95 plus. So it is very hard to find. And if the model is giving you 98 and 99% of accuracy, it is overfitting. That you have to definitely take care on your training data, and what classes that you're training it on. So that you have to definitely take care of. But mostly you will do that when you have a very small data set and it overfits and you can't do anything. So, unless you add a lot of data to it. When you try out things in a very small scale, you get 98% accuracy, 99, maybe even 100 for instances. When you have very small data set, let's say 1000 or 2000 rows of just two classes, then it is more likely that it will give you the right answer 100% of all the data that you have shared. Cool. So final bit, so I won't take much of your time. We have 8 more minutes to go. So what is the present and what will be the future? So as I said, copilots is one of the things that you guys have to adapt to. So it is not like, no, I won't use Copilot, I'm better than Copilot. You don't have a grudge on that as well. And you have to leverage the technology. That so GitHub claims that there is a 50% plus productivity time improvement when people are using Copilot. So I can't claim that it can be true, or GitHub says that. And but it helps you in a lot of different ways when you have to do things faster and quicker, and not learning stuff, right? So it can give you the solution, but the process of learning it, and then let's say if there's the problem comes next time, and then you should be able to solve it on your own and not rely on Copilot. And Copilots are not going anywhere. It is here to stay. It is not blockchain where there's a huge hype and then it goes back. And there are a lot of people saying that the hype is not enough. So I have heard in a couple of conferences this year where people are saying the hype is not enough, but the hype is obviously at its peak enough, with Nvidia's share prices going out of the roof. And it's becoming more and more common with all the GPUs they sell, and more and more process and frameworks that they build, and companies which utilizes their GPUs to build cool stuff. So it is highly unpredictable enough, but the LLMs are here to stay, obviously, as copilots are. And you have to definitely adopt to things. That is one of the things that I have started doing. So I initially was not very much comfortable using copilots and things where I can go to the documentation, search it myself. That is how I was doing it. but still now I have started once I started using it, and there is this problem where you stop using it, and then it feels like you are doing some extra effort, right? So what happens is when you I thought like we'll stop, we have been using it for a month, then we'll say we'll stop it and then see how good it is or what is the impact that we have. So it you just feel that it is somewhat missing, since what happens is you just type something and then keep pressing tab, and then you get all these cool stuff getting filled out, and then that no longer happens, and then it is very hard for you to digest, and then you have to type everything on your own. It is a huge pain, right? So you will get the huge pain when you started using it, and then it is like an addiction. It is not like an addiction I would call, but it is some you feel, you will definitely feel that something is missing, right? So once you start, let's say typing something, and then you get all these cool predictions, and then you just press tab all the way around, and then you just start typing method names, and then it starts filling out everything with the correct data types and variable namings as well, which how you would do it. So it is very hard for you to type stuff. Maybe GitHub was right where you have a lot of productivity gain when you just press tab all the time and not type anything, right? So that is one of the things that you would definitely feel when you stop using copilots. At least say even for a day you stop using it, you will feel that there is some part is missing on your in the way that you write code. So definitely give it a shot. I think it is not free though, but definitely give it a shot and see how it is. And companies adopt, and people investment is one of the things that we have to definitely kind of understand, how things are evolving, not just tech evolving, but who is investing in and who is developing things. So LangChain is one of the things that have come up in recent times, and it's been more than a year, I guess. They have released their first version, and it is one of the tools that you have to definitely use if you're using LangChain with, building custom chatbots, or maybe you're just building a customer service, application, for an example, for any of the websites or vendors that are out there. So those are the frameworks that people invest time in. So it is not like one person doing all the coding, but that is a effort of hundreds and hundreds of people where you contribute to the open source, and then there are a lot of bugs that people raise, and there are people who are ready to fix the bugs, right? So since it started picking up and there are more developers who are investing time, it is not just the money that is getting involved, but it is also the developers time. You can invest as much as money that you want, but people should be willing to write open source tools and code for it, right? That is one of the factors that will decide what will be success in the future. Since if let's say you just give 10 crores or 20 crores, but nobody is willing to write a code for you, then there's no point in having that much money as an investment. So that I think GitHub, or at least the open source community, is very strong with LLMs and all the frameworks that are coming up, and there are a lot of open source LLMs out there which are not that big as GPT-3 with billions of parameters, 175 billion to be specific for 3, and I think for 4 it is around 1.7 trillion. So it is going to increase with 5 if it comes out this year or maybe next year, I'm not sure. So it is going to increase the parameter size, obviously. So there is a huge jump. So there's a 175 billion and now it is like 1.7 trillion. So it is a huge leap. But 175 1.7 trillion is not an official number. There I have written few blogs, it is 175 or 176 in Wikipedia it says. So it is going to keep increasing. It is not never going to decrease in the near time. But there are open source LLMs which are like 7 billion or 10 billion. So there are very very small models which people have started focusing on SLMs, which are small language models, where it is more specific to a particular task and not generic enough, right? So let's say there could be a model which is very good at writing poems or poetry, but it is really bad when you ask a program, let's say write a prime number program in C++. So it might be really bad, but the task of that particular LLM, that SLM, is to give poetry and not code. So more and more people are focusing on SLMs where they fine tune and train small language models specifically to their use case, rather than using a generic model and then trying to fit their use case. So that is one of the things that is upcoming as far as I have seen and spoken to people around. So those are the things that you can definitely keep a watch out of, and you can definitely keep yourself updated with all that, maybe on LinkedIn or Kaggle competitions. There are a lot of Kaggle competitions now. Even I have seen a lot of Kaggle competitions where you have to predict the words. So there is a recent Kaggle competition that I was looking up this morning. So you have to predict words for 20 questions. So I was not very sure of. I was just reading through it. I didn't completely understand what they were trying to say. But you can definitely look up. Kaggle is one of the great resources to look up for competitions, as well as what people are expecting in the industry and what is happening across the industry. So I think that is all. So if you have any questions, definitely feel free to drop it in the comments. So we'll take questions for 10 minutes, I guess. We are already 8, but still, we'll have questions for 10 minutes.
So hello sir, like we already have a question in the chat. So a guy asked you about his like what was your personal project in your final year, and like can you give him some insights like what he can develop inducing machine learning?
Sure. So my final year project, as I said, was a leukemia classifier. So we had, I think, 4 different classes. So we had around 10,000 images, around 10,000, and each were around 2.5k, which was close to 2.5k. And there was this particular class which had around 300 to 400 images, which is very rare, that particular cancer type. So we had to do this image augmentation and things to get good number of images to be to get this underfitting problem right. So that is the project that I did. I think I have that as an open source code in my GitHub repo. You can definitely check it out. And yeah, that is for that. And second question, I sorry, what was the second question again?
So well, he just wanted some insight. Well, he just wanted some insights like what he can develop on a basic level in using machine learning, considering he don't have like that much prior knowledge, but the college professors wants him to like use machine learning in his project.
So mostly what people can do, let's say, since everybody is going to do the same thing at the end of the day, where you have to build a machine learning model, you have to deploy it. But to stand out, I would say, let's say there are a couple of people who are listening from the start, where you can build a data pipeline wherein you can retrain the model dynamically based on, let's say, if there are new values coming in and then the accuracy is decreasing for some reason, where you can have a backend pipeline which feeds new data into it, and then you can also ask for user provided data. Let's say if it is classifying apple as orange, then you can say, then you can get a user feedback. So even in ChatGPT, there is an option where you can thumbs up and thumbs down for the answers that it is giving. So they are getting the user feedback so that they can make their models better. So in the same way, you guys can do it. Most of the ML models, ML projects that I see, they train and then they deploy and then they show. So those are the that is the most case. But if you want to stand out, or if you want to extend at least the current project that I had, you can definitely build this extra data pipeline which feeds in data to the model. As I said, feedback is one of the critical aspects of, at least in this particular industry, where it is really critical. If you say no, if you do a false negative, then it is really bad for that person. So it is it is recommended that you do a feedback cycle, and then you loop it to the training part of the model, and then you swap the models regularly. So you don't have to do the training every day. Let's say you have a metrics of, let's say, the accuracy of the model is decreasing, and a lot of users are reporting the accuracy is bad, which you are capturing it somewhere. And then you can start training the model with fresh data, or even just with the feedback. Let's say if there are 1,000 feedbacks that this particular classification is wrong for this particular input, then you can definitely add that to your training data set and retrain the model all over again. Or you can fine tune, you can train over the model that you already have. So I think those would be the standout factors, that if you want to do it, further develop what people are doing, or what at least I developed.
Okay, sir. Like that was a really good insights on some project ideas. And other than this, there is someone who has asked, can you share some insights on developing an algorithm? Like I guess you mentioned when you were explaining the AI part, okay,
Mm,
how does it like it's important to developing algorithms and know mathematics. So yeah, we would love some insights on that as well.
sure. So for the algorithm development part, so as I said, you are in the first part of the category where you are trying to understand things in a much deeper level. So to develop an algorithm, it doesn't just come from nowhere that I will develop this particular algorithm and it will be good. All right. So let's say if there is a pain point in that particular algorithm, right? Let's say if the decision tree is not good enough, you try to kind of let's say I know this is the problem with the decision tree. Can I make it better? Right. So that is how you kind of come up with a new algorithm altogether, or you kind of try to create another layer on top of the existing one, and then you rebrand it to whatever algorithm you want. Most of the cases it is second case where you kind of rebrand it, and you have to show significant improvement in the performance, obviously, and in whichever algorithm that you develop. But developing it from scratch, you can do, but a lot of big tech companies should be already working on it. Let's say GAN is one of the things that came up long back, not long back, maybe 3 4 years back, where they started generating images altogether, right? But now even with the GPT-4, you can input images, it can recognize, with Dality you can generate images, which is one form of GAN. But to develop something like GAN, which was not there, let's say in 2018 or 2019, nobody thought you can generate stuff, right? It was just classification of things. It can tell you that it is whether this is right or wrong, or it is true or false, or it can do segmentation, it can do classification, it can combine things together with similar metrics and factors for clustering problem, for example. So all these things were tasks that are human based, right? And then GAN came out of nowhere, and someone would have been thinking, why can't we generate stuff instead of solving something, right? So these are two different problems altogether. So the first part I was talking about is, let's say you have the problem with the decision tree, and then you kind of take that and do something complex and come with random forest. So it is very similar to that. Either there are two tracks where you develop something from scratch. Example, decision tree and GAN is no way related. Decision tree, you give it a task and then it does it. So GAN is also a type of architecture. You have to have a generator and discriminator, which kind of gives you the fact. It is also, it can, you can call it semi supervised. It is not like supervised. The discriminator is obviously supervised, where you feed information. But these are way two different architectures altogether, and two different algorithms altogether. So algorithm and architecture, you can, again, there is a difference in algorithm and architecture, but architecture is a more good word to use it over here, where you know that there are huge difference in how things are handled. Since there is no user input in GAN, let's say you keep generating images, and then discriminator says whether the image is good or not. If it says it is good enough, it is not fake, and then you get the output. So these are two different architectures, for example. So either you can think of something from scratch. Let's say somebody would have thought of GAN and then say, okay, we'll develop this algorithm and then we'll publish it somewhere as a paper. And this is second part is where, okay, this is a problem with the decision tree or any algorithm, for example, even with GAN. So this is a problem, and I can give you better solution to it, and then I can rebrand that particular algorithm or a structure into a different name. So those that is how you kind of if you want to really do the deep dive in algorithms, and if you want to develop something on your own, and then you can definitely name it with your name and co-authors of the paper. So if you want to really do it, then that second option would be the go. But ideally, you can try to do the first one. So Second one is, there should you should find a problem which nobody is solving for. If you're going with the second route, that might be very very hard. That might be very very hard if you're not into the industry and if you have not done a lot of work around. It might be difficult to find a problem statement which nobody is solving for. But the first one is very much easier. It is not that easy, but it is easier when compared to the second one where you have to develop from scratch. Again, the first one also requires a lot of detailing, a lot of study of the existing architecture frameworks, existing usage of the particular model. Since if you're developing a good model and nobody is using it, then there's no point in developing that algorithm in the first place. So that research has to go into the picture first thing, before you do development of any architecture, even the first or the second. If you're developing something better than decision tree, and if nobody is going to use it, the adoption is very less. So adoption will come when there are two things, right? Once you do a good exposure of this particular model to developers, or second where it is really good and outperforms most of the existing models, right? YOLO is one of the models which every year they compete in uh, the classification image classification competition, and I think it is still going on. When we started, we had this YOLO V1, V2, V3. Now I'm not sure which version number it is now, but every year there is a competition where you have to classify all these 1,000 images, and they compete with all these different algorithms. So I think that is a good place that you can start with, if you are developing a new algorithm from scratch, or if you are just updating something. So that could be definitely doable, and it is not really hard to develop. So we were using, I think, I'm not sure on the exact name. So in Keras applications, there are these pre-existing models that you can use, and the output layer has 1,000 classes. So what I did is we have removed three layers from the bottom, and we added four different classes. So I'm not sure on exact which one I was using, but we did that. So it is the tweaking of architecture, and changing the activation function on all these tweaks should make the model better, or it should adapt to your particular use case. So that is something that you have to definitely think of. But the first thing you have to think of is the usage and the adoption. If you are trying to sell it to public, or maybe you're trying to push it to public for more adoption, or if you're just trying to learn stuff and then implement something, you can definitely do first any one of those without any hesitation. So it is totally depend on what your goal is. Either you're trying to learn things by developing an algorithm, or you're trying to commercialize something, or if you're trying at least to push for more adoption and getting feedback. So that is definitely something that you have to look for before either you start developing something from scratch, or modify the existing algorithms. So I think that should answer your question. If it is not, please let me know.
That's how you answered it really well. I think so. Like, guys, do we have any more questions, and or should we just wrap up? Because not many folks are left here, I guess. Uh, okay, then since considering the response from the audience, I guess Sir has covered like every aspect of your questions and all what you have answered, like all what you have requested. So, sir, thank you so much for taking this session and introducing our audience to like all these topics. And the like insights were really deep rooted, from creating projects, also deploying them, all what problems a person can face. So, like, sir, thank you so much for coming, and we'd love to have you in like future sessions as well. So,
My pleasure.
okay, sir, thank
Thank
you.
you.
Okay.